So welcome, Dan.
Let me get this going here. Okay.
Great. Welcome. This is fantastic.
Can you see that, Susan?
Yes, it looks great.
Okay, super. Well, hello, everybody. Happy Tuesday. It's a little hard to believe that it's already the middle of August, but here in Tulsa, Oklahoma, at least it's been cool the last couple of days. So that is a relief. So today we're going to be, talking about a number of issues with kind of an ethical basis. I've done ethical training a few different times. So as we look at that, pardon? Here we go. So as we look at this from an ethical perspective, before we get into the details of this, just in the training I've had and so forth, I want to make sure that we look at this that at least in part, what we're trying to do is focus on facts, trying to be unbiased, leave political views, all that kind of stuff out, try to remain technical, definitely not forget history, and just to know we're always learning. So this is, I think that that as we go into this, sometimes we can get a little bit full of ourselves or whatever. So it's always important just to kind of remember some basic things. So as we go through this, we're going to talk about data and so forth, and happy to have questions and so forth after we get done. So first, we're talking about orphan and idle wells. There's been a number of estimates of this from, the IOGCC and the USGS and the Environmental Defense Fund and so forth. And, you can see the numbers here. EPA has estimated, upwards of 3 million. But, just looking at the idea of documented orphan wells, there's a number. But the other thing that we have is idle, inactive, uneconomic, non-producing oil and gas wells. And this map here excludes orphan wells and is essentially just non-producing or inactive wells in just the kind of a little bit of the mid-continent area, to give you an idea. So this is a big issue. And when we start looking at the numbers here, what we'll talk about a little later is just incentivizing this, the depth of the problem. I had a webinar just a few weeks ago with American Petroleum Institute, just letting them know that these issues are coming abreast. People are being made aware of so many different things. And it's an issue that we all need to work together to do our best to resolve. So as we go through here, you've seen what Susan sent out earlier, and we're going to talk through a number of different issues. So I'll just take these kind of one at a time. So first, best practices, and just like the idea of well plugging and planning details. It can get complicated. I'm not trying to throw all the different details in all of this, but just to throw some highlights in here through these things, because this isn't a 2-week workshop. This is a hour-long presentation. But I will say that just making sure that you're familiar with the regulatory requirements, which can be a little complex sometimes, because sometimes you may have a local entity that with ordinances like a city or county and a state and BLM or BIA, and just a lot of different issues, making sure you have proper site access, that you're doing testing, addressing safety. The safety part is a particular, I'd say, priority for me, just because I do a lot of expert witness testimony and have had to deal with stuff with blowouts and injuries and fatalities on this stuff. And so, and a lot of times I see that with people kind of downplaying the significance of that. but area issues and developments, so as we get through over time, just understanding what's happened from the time, say, a well has been abandoned or stopped production, and other things that have happened in the area, past issues like blowouts on other wells in the area, so that maybe you are expecting or anticipating that in plugging design and processes, looking at risk management planning, historic well records. And I'll just say, making sure you realize that a lot of times historical well records aren't always exactly as accurate as we might think. Locations might have been put together with different land grid systems, or there may have been mistakes in that. I'll just tell you, the state of Colorado, and I've done a lot of database work for state oil and gas agencies, and when we started working on the risk-based data management system around the country, and looking at existing data, we found that, say, Colorado had wells that were located in the Gulf of Mexico, and the state of Montana had a well that was 100,000 feet deep, and California had wells in the Atlantic Ocean. And it's just, these are like kind of simple data entry errors, but it's stuff that you need to make sure that you can confirm and so forth. So just, looking at that past data can be really critical. So area characterization, well types, whether it's oil, gas, it may be an EOR or injection well or geothermal or some other sort of thing. Just understanding the details of that reservoir, the geology, how the well was built. We'll get into a lot more details of that, but all of that's important. The well plugging design, working with the regulatory agencies, but also looking at history and the things that we just talked about, the geology, hydrogeology, and we'll talk about this again later on, but things have changed regulatorily. Groundwater aquifers can recharge, or there can be communication between surface water and groundwater, and it's a very complex thing. And that's, why in all of this, I've really been trying to push not only to the Society of Petroleum Engineers and AAPG and others, that we need a multidisciplinary approach when we go attack these issues. But there's also ideas of locating wells. Sometimes they can be just boogers to find. They take a lot of effort. I have a ranch out in Ohio next to Stumptown Road, and all the trees there during development in the early days of oil and gas were taken down for building derricks and all the things, and it's forests now. So just having access can be a challenge. And then quantifying, characterizing emissions. So if we're looking at things like carbon registries or other incentive programs to do that, or even helping the funding agencies at the federal level understanding and be able to document the positive impacts that you're making. All those are important. I will say, I'm going to go back to this real quick. So we're doing a project for the Groundwater Protection Council right now, funded by DOE's NETL. And we hope to have that out here over the next couple of months. But what we're doing is kind of a best practices document for Orphan and idle well plugging. And it's not a tell you what to do or how to do it. That's really what the job of the regulatory agencies. But what we have done is accumulated a lot of historical documents and information and methods and equipment and materials used for plugging and all that to be kind of a reference sort of document. So that'll be out here shortly. All right, priorities. So I realize we're all can look at this and so forth, and there's a number of methods that have been used by state agencies, federal agencies, and so forth, and trying to prioritize, well, is it by a house or whatever? But it can be pretty much of a challenge. We've seen, I've been in litigation where houses have blown up, where we've had to take various issues where we've had methane emissions in and near houses, into groundwater, into a variety of different things. So really, looking at those things on an overall basis can be critical. I will also say that too often I think we look at, kind of groundwater or soil contamination being limited to, influenced by, say, hydrocarbons like oil or brine. But I'll tell you, groundwater contamination can also come from, stray gas emitting from Orphan and idle wells and such that can cause real problems. So we have to look at this with kind of an open mind, I'd say. And there's been a lot of cases where the presence of gas emissions has been an issue. I visited one site in Ohio along a river for a well that CSR Services recently plugged, where the locals had a kind of a continuous flame roaster for their hot dogs and all that stuff, that they could just go out there and they knew where to go and light it up, and they had a fire. And so there's different things that will stun you. So these pictures on the right, and I like pictures just to give folks an idea. This was a well that was plugged in New York. And what was kind of interesting about this, not like the story I just told you, is a lot of the locals here would come out and light it on fire, and have parties out here on Friday and Saturday nights, I guess. And fortunately, no one got injured or killed, but this is just one example of something that's a real problem, where you have both emitting brine as well as emitting gas. So as part of our goals, we want to ensure that when we go do plugging, that we're doing that on a permanent basis. I'll tell you that I'm a lot less worried about that in 2023 than what I've seen happen on wells that were plugged in 1900 or 1950 or even 1970 or 80. And I started my career with Halliburton in 1980 as a bulk material equipment operator, driving cement trucks and all that. And the type of materials and approaches that we had then, and especially if you look, say 100 years ago, were not great. And I would also say that at those past times, you couldn't always anticipate what was going to happen as you move forward. So being able to really understand and try to anticipate what's going on and modify that is just critical. So we do want to quantify emissions. There's a number of different methods for that. We want to address remediation, reclamation. This is like, if you're doing that, we're doing a project right now out in New Mexico that's on state lands. We're working with state land office and OCD, and so making sure you work with all those and are doing all the various things. A lot of those folks have some great experience, but you still have to look at to make sure you have folks on your team that can address that and be prepared for risks like stray gas. We don't want any more zombie wells. We want to be able to manage historical equipment or other details, and just experience is critical. And I'll say that one of the things I'm running into now is, this arena is really expanding. And so you're getting a lot of people out there that have limited experience. And I'd say that we're gaining experience rapidly, but having that experience on your teams that are doing this is a good thing. So for all you old guys out there that have been around a day or two, you are absolutely needed. All right, so we're going to talk a little bit about methane. This is important from a couple of different perspectives, whether you're trying to understand where things come from. So if you're, let's say, in Appalachian, you're trying to plug wells, we might want to know isotopic analysis from the data, so that we can know if this is deep gas or shallow gas or intermediate gas, so that we can know how to help design our plugging procedures, but also measuring that if we're looking at pursuing carbon credits or reporting to governmental agencies and so forth. So a number of things going on here that we need to prioritize. So there's a lot of people doing this. We do a lot of OGI camera work, but we're trying now. There's a lot of efforts with universities and federal agencies and groups like the Well Done Foundation that are doing a lot of this relative to perhaps working with American Carbon Registry or one of the other registries that are out there on just measuring the emissions from some of these wells. I've got a well on my property in Hectorville, Oklahoma, that we use for training because it's leaking quite badly. So I'm hoping that we'll be able to get that plugged here before too long. But making sure that you're addressing that in detail is critical. And I'll say that one of the things that I would say is hard for a lot of us to really understand is this has become such an issue of focus, that really making sure that we get this right and understand it and so forth is just a major priority. So if we look at some of these emissions, and I'm including some kind of OGI stuff here because we can have meters and all that, and those are great. But the video cameras where you can see this with with an OGI camera, regardless of which one you're using, it just being able to visualize that is significant. So it can be observable, it can be measured. I'm not going to go into all the details, but I will show you some of the options. But it's a huge issue just in the United States. But I will tell you that I've run into some cases where people don't understand that methane is flammable, and that you can get into trouble. I'll tell you that with the Well Done Foundation and a number of other groups, they have a good focus on safety and just recognizing this, which that's a great thing. So some of the measurement tools that are out there, and there's a number of them, Vent Buster, AlleyCat, Vent Meter, Vent Nanny, Vent Medic. There's a lot of tools out there. If you've got questions on any of these going forward, I'm happy to talk to anybody about the various different things. I thought about putting a table in here that kind of compares them all, but they can be pretty specific on what you're doing. I'll say that we use a lot of these tools also on active wells when we're doing gas migration investigations, such as like in the state of Pennsylvania. So, but if you're pursuing credits, I would just encourage you from that carbon credit registry perspective to really look at these. I know for the ACR, Vent Buster is approved in what they're doing with Orphan wells, but all of these are there's a lot of very good tools out there. All right. So, and I know we're moving fast, but we got a ways to go and not that much time. So, significance of historical and area information activities. So I am a big believer that understanding history is critical. We tend to want to look at things through today's eyes, but historic practices were very different than today. API wasn't founded until 1919, so all those standards and stuff that they've come out with, which they've done some great stuff, but a lot of it wasn't present then, or it was or early on it was maybe not the specific priority. But if you look at some of the standards that were out there, some of them had very different ways of doing things. Most states didn't really have applicable regulations till around the 30s, really, to even have anything. Industrial practices, they varied substantially, whether you're depending on what part of the country that you were in and the type of equipment you were using and the purposes and all that. So I just say, as you're looking at this for the area that you're in, there's a lot of resources out there that can give you some insights to the past. And I'll say one more thing on this is Susan mentioned the image conference. I'm going to be part of a panel at that conference, I think on the last day of the conference, and I'll be doing a presentation on the history considerations for orphan and idle wells. So I hope you guys, if anybody's going to the conference in Houston, come by and listen. It's going to be a great panel on orphan and idle well plugging and so forth. Okay, risk management. So as I noted before, methane is flammable. It's a VOC. It's a greenhouse gas. It can provide a lot of hazards. There's been a lot of buildings and so forth that have been put on old wells. Here in Oklahoma, we have a lot of man-made lakes, so we have thousands of old unplugged orphan wells under the water line in a lot of these lakes. But I'll tell you, I've also plugged a pre-1900 well in Michigan that was actually in Lake Michigan. It was up in extreme northwestern Michigan on the lower peninsula, but wooden casing, the whole thing. So but looking at these risks and so forth and understanding the details of them is pretty critical. The picture here is from Ohio, and had an apartment complex go in, and they started having methane issues in the buildings, and ultimately found that the facility was built on some gas wells, and so they're doing venting, but they have not, at least the last we checked, we're not able to access the well to replug it. So these can be considerable issues. So and I'll also say one of the challenges I have when we look at risks and considerations, and I don't quite understand how this got started, but or the priority. I do, but it's hard to think about, is we look at orphan wells or idle wells or well pluggings as individual wells, and really know their place in the oil and gas industry, or as we develop fields and so forth, or leases, or traps or so forth. Do we think of things on an individual well basis? So what can happen is I plug one well that maybe is a problem, and 15 other wells are a problem. So we have to be really cautious of that. So we did a project, this was years ago, in Southeast Kansas, and kind of that's slim hole country. We go to plug a well, and we knew that there was some other undocumented ones there, and we pumped compressed air in the ground and found 11 other wells within a stone's throw of the first well, and wound up plugging all of them. But if you go in and just plug that one, then one next to it maybe starts becoming a problem. So we've got to look at these things, I believe, on an area basis, and that's my opinion. But I think from an ethical standpoint, we tend to look at view these on an individual well basis, and I think that we're kind of missing the boat a little bit there. And when we look at what some of those risks are, these are just a few pictures of you get a welder on there. I had one case where a welder goes on to mount something on an old well, and pops open his welder, and gas blows up in his face, and he's injured. We've had cases where houses were built over old wells. I've got I live in Tulsa, Oklahoma. In the 60s, there was just like 2 miles from me, a house and a school were built over a small gas field, and they had to go back in and plug those wells, and they were plugged, but stuff can happen. So we've got to really be aware of the hazards. We've seen countless cases of people plugging wells in driveways or between houses or so forth. So just really looking at those risks. Some of them can be underwater, under structures. We've seen some where, you know, well goes in, it's abandoned, and then years later, somebody comes in and puts in a gas storage field next to it or around it, and then the well starts venting gas. You know, other issues where this is in Appalachia where you know, new Marcellus development is going in, and you frack a well, and then all of a sudden gas starts coming up to an old well that has no casing or anything, because a lot of people tend to think that, you know, old cable tool holes can only go down like 500 feet, you know, and if you have been around a day or two, you realize that the deepest cable tool hole drilled is in New York and is in excess of 10,000 feet. So it took a day or two to do that, but, you know, I'm just saying that sometimes it can surprise us, you know, just what history has in store for us. So we need to be ready. So permanence is a big deal here, and that's I think a significant deal to me. There's, you know, the Interstate Oil and Gas Compact Commission and SPE and others have had a lot of stuff on really trying to make the plugging work that we're doing permanent, because we have a lot of cases where we have plugged wells around the country that are now leaking, and some of them are becoming what they might term zombie wells or whatever, or for a variety of different reasons. I know we have one area like in Texas that we're working in with a water drive reservoir, you know, 4,000 feet deep wells, and the reservoir, you know, it wasn't depleted with pressure when it was, you know, when production was stopped. It just, you know, they weren't making any significant quantities of oil or gas anymore, but you still had 2,500 psi of a water drive reservoir at 4,000 feet, 3,500 to 4,000 feet. So you got a lot of things going on there, and they've had trouble over the years in that particular area with some of the plugging. So you've really got to pay attention here to make sure that you're doing what's needed. So this is a presentation, or from a presentation that the Alaska Oil and Gas Conservation Commission put on last year. So they're really working on a lot of different things and trying to focus on their plugging, as all the states and regulatory agencies are, to keep these, you know, the work that's done to be a permanent plugging event. And there's a number of plugging guidelines out there, and just looking at the intervals and so forth, I would say that, you know, generally what I've seen is a minimum plug length of 100 feet. I'll tell you that here in Oklahoma, if you go talk to Brad Ice or Danny Ray or others, they're seeing a lot of issues with plugs that are only 100 feet. And I would say that throughout the country, you know, we're seeing that some of those minimum plug lengths increasing. And I would just say more details of this. And I'll also say, and I think I had this in a prior slide, but as part of the IIJA BIL funding, there's money in there for the state regulatory agencies and the feds to expand environmental regulations or regulations applicable to well plugging. So I would suggest all of you really look at expecting expanded regulations on those lines. But as you are doing these, or if you're designing the plug jobs or whatever, I would encourage you to look at what's happened in other plug wells in the area. Have there been problems? And that may encourage you to go, you know, they used 100-foot plugs at these 10 different wells over here, and all of them are leaking. So we're gonna do things a little bit more detailed. I'll tell you another company that we're working with that I think is doing a good job, and this was work done through funding through the Department of Energy, but the whole idea of biomineralization technology on using that for remedial squeezes, for well plugging and other things to permanently stop gas migration is huge. I can tell you, I've done hundreds of well remediation projects in trying to stop gas migration through, say, a microannulus or channels and so forth. And it's hard. And I would say many times I've had to do multiple remedial squeeze jobs on a well, and that's been using, say, microfine cement or resins or different additives in cement and so forth. But one of the things I like about some of this biomineralization technology, like what BioSqueeze is doing, is that it can fill a very small gap. And that's significant when you think of, say, a microannulus. We don't have to necessarily, it's small enough where generally water is not going to move through there, but gas will. So when we start looking at that, it's, we have to have things that are going to stop that gap. And there's certainly other options too, but this is a good one. So I'd encourage you to look at it. All right, documentation. So these are three different wells that were plugged and abandoned here just in Tulsa, Oklahoma, at the Turkey Mountain Wildlife Area. But what's interesting with all of these, and when we look at plugging, the first well a little bit north of there was drilled in 1901. This area was, I would say, was probably most developed in, like 1920-ish time, 1930 even. But this first one, the Benjamin 3, was 1911. Just north there, the first one that I think I'll have in this one was in 1901, and the Glenpool 1905. But when you think of this back then, if they would drill a well, they typically didn't cement, because if they hit a dry hole, they wanted to reuse the casing or use the casing while it was producing, so that then they could pull the casing and again reuse it. So this first one, it was plugged. So it is technically plugged, right? It's plugged. And it was plugged by filling the hole with a mud-laden fluid from top to bottom. So you got to think, these are formations where they produced, oil, water out of this for a while, and really stopped making much in the way of oil. The fluid level was way down, so they just, filled it with a mud-laden fluid. I've come across hundreds of wells in areas like Osage County, Oklahoma, which is, we don't have reservations in Oklahoma, but it's essentially a reservation for the Osage tribe, and was a big initial development. But many of the wells there you see were plugged with brine, with no casing, and then all of a sudden, sometimes, those wells can act back up. But in this one, so the Bishop 6B, dry hole, production casing cut, 3 plugs placed in 1972, no construction record, no geologic record. The Bishop 3A, drilled in 39, all the, the casings were pulled, no plugging record. And one of the things that frustrates me is we tend to, when we look at this stuff, we go, okay, there's a plugging report and the well was plugged. So it doesn't now count as, say, an unplugged Orphan or an unplugged abandoned or whatever well. So we got some of these that really, have an issue or a potential issue. In 1966, there was a well in Hennessy, Oklahoma, that was, filled with mud-laden fluid, and at one point, I think this was probably, they didn't really do anything to determine causation, but it suddenly was shooting fire 100 feet into the air, flames, and had gas in it, and they had to plug it, but it did quite a bit of damage. So things can happen, and I just encourage everybody to, as you're looking at this, and even doing new projects. So we're looking at doing things like geothermal development, CO2 sequestration, CO2 EOR floods, and all that. Is you really have got to look at these old records and try to understand what you might be dealing with, so you don't run into problems. So some of the this modern documentation requirements. So for regulatory agencies, It can vary depending on, local, state, federal, but you generally have a plugging plan that gets approved. You have maybe logging, you got to do site restoration, plugging and site restoration confirmation, and then maybe a final report. But on the carbon registries, you got, requirements, and they'll vary. There's a number of registries, and I've got a little table. We'll talk about this a little bit later. But some of the common requirements, you've got to have plugging plans approval, leak confirmation, measurement, gas analysis, surface mineral ownership details, plugging confirmation, documentation of project emissions. So like for the registries, you have to also account for the emissions by the equipment and so forth that were used during plugging that you essentially subtract off. So I would just say there's a couple of different angles here that you just need to be aware of depending on what your plans are relative to the well plugging activities that you're going to be undertaking, and making sure you don't miss them. So I know I've had people come up and are worried about this and have sought me out to be able to say, hey, we're getting ready to do a bunch of wells. We want to make sure we do it right. We don't want to mess up and miss something, up front. So I think that's a good thing. And, I'm a big, plan. So repurposing opportunities, and this is, I know, an important thing to Susan and AAPG and a lot of others. And there's a lot of repurposing that is being thought of today, whether it's, using wells, the University of Oklahoma has repurposed some wells for, geothermal energy development. We do a lot of stuff around the country where we repurpose wells. We partially plug them and we'll repurpose them as water supply wells and so forth. But there's a lot of examples. This is one that we've actually worked with, and this is a Smackover formation and lithium extraction from them. This area really interesting, and I wouldn't have said this just a few years ago. We've done work in the Salton Sea of Southern California, where you can get lithium concentrations of about 500 milligrams per liter. But in the Smackover, I've now seen laboratory results of lithium concentrations over 600 parts per million. And in Arkansas, Exxon recently purchased, prime mining leases in Lower Arkansas for lithium development. And this is, I would just say, if you're familiar with this, there are some major land runs going on right now. So understanding that Reynolds member of the Smackover and the details of this and the potential for this to go, I show this going over into Texas there, but there's potential for this, for the lithium concentrations, maybe not at 600 parts per million, but maybe going all the way down to the southern border of Texas, along with geothermal. So looking at those combinations there, but some of these old wells certainly have potential to be reutilized for lithium mining. And I'll say that, and when I say old wells in this arena, just keep in mind, we have idle non-producing wells that were drilled maybe only a few years ago, or dry holes. So some of the tests that have been done by, say, Standard Lithium in Northeast Texas were, drilling out existing well bores that were into the Smackover at 10,000 feet and getting samples of lithium to help them understand their land grab. But it's interesting when you look at, at these very first development of the Smackover formation, and you have to call it Lower Arkansas. They don't call it Southern Arkansas. They like to say LA. But nonetheless, it's great thinking that that Lower Arkansas could have a real big boom, as well as Northeast Texas. So if you know anything about these areas, these are not high economic areas. So the fact that you have this potential there that could create a lot of jobs for people and other stuff. So there's some really big win-win things going on. So prioritizing wells plugged, these pictures here are pictures I took. This is Tulsa, Oklahoma. That's the city of Tulsa in the background. And yes, those are old oil wells sticking up out of the water. The problem with some of these, I'll just say, as we look at prioritizing, we have a big focus right now on wells, prioritizing wells that emit methane. But a lot of the wells don't emit that much methane, if any. And so that's one of the things that I'm looking at and trying to work on is how do we gain prioritization or carbon credits or something for some of these wells that they may not be a problem on an ongoing basis, but they sure could be a problem, like the example I gave you from the wells from 1966 in Hennessy. But you can have a lot of challenges, wells that are out in the water, deteriorated or corroded casing, wells by houses. I mean, this one, the upper right in New York, I mean, adjacent to a structure, and some of them can also be not only emitting, say, methane, but are emitting brine that is then going into a creek or something. And, so there can be a variety of challenges in these, as well as what I mentioned earlier is access. So we've got to really be thinking about this. And as we start thinking about ethical considerations, just making sure that that we're putting all that into place when, we're going out maybe in a lake or next to somebody's home, that we're really taking the necessary precautions and so forth to do this thing properly. Okay, so prioritizing future production potential, as well as considering mineral interest owners. So one of the things, the well on the right is this is an example from Texas, what I was talking about, the Water Drive Reservoir. But what we think about on economic life of an oil and gas well, it can vary by location, by type, conventional, unconventional, so many different things. But that economic life that turns a well idle can be impacted by water handling costs, operational costs, hydrocarbon production levels, commodity pricing, a lack of alternative producing zones or options, maybe the wells in severe disrepair. I was talking to a gentleman over the weekend that had some conventional wells in West Texas that he had to plug because the wells were producing like 20, 30 MCF a day, but there's such an overabundance of water in West Texas in the Permian Basin, and a lot of the commercial saltwater disposal wells have been locked up by midstream companies who have contracts with big producers and so forth, and they had nowhere to take their water, so they couldn't produce them and elected to plug them. So it could be for a variety of different reasons, and that's, I'd say, changed and evolved over time. But my point here is that orphan wells and idle wells or inactive wells are also past their productive life. So when plugging and cleanup liabilities are considered, these are already past their time. And I know Dwayne Purvis, I think he was signed up for here. I'm not sure if he's on the call, but he's done a lot of stuff just in looking at this economic life. I know I've done a lot of work on acquisitions and divestitures and going into assets and looking at, say, plugging liabilities that you're getting into. And I've told multiple clients is like, if you want to buy this, you need to tell them, if you give me $100 million, I'll take the asset. And sometimes it's that significant. So I hope that we fully recognize that as we go forward and what some of this is going on. Now, with that said, there are wells that have been around a long time, so this is the Sarah Bland well. This is the first oil well in Tulsa County, Oklahoma. It was drilled in 1901. I was out there a few weeks ago with my kids, and it's still producing a 1/4 barrel of oil a day. It's produced, over 100 years. It's produced over 1 million barrels of oil. It's a great story, but I know that I'm not sure that this well is economic, that this isn't, like, a lot of this isn't the group that owns this well just knowing this was the first well and they want to keep it there, because I know they spend a lot of time out there. But nonetheless, having wells that have been producing or still producing over 100 years is few and far between. So we can have the Sarah Bland wells, but just there's not that many of them. And we have wells up, in Oklahoma and Kansas and Northeast Texas that I've seen that are producing on rope pumps, if you even know what those are, that might produce, a couple of quarts of oil a day. So there's still that out there, but the economics of that and so forth has just gotten challenging. So now when we look at that, we've got, carbon offset considerations related to these. This well in the picture is a well that I worked on plugging back in the mid 1980s. That's the Wabash River. So let's just say it was a hoot getting that well plugged. But nonetheless, there's other things that we have to help incentivize getting some of these wells plugged that is really good. So right now I would say that we're in such a neat time. So, the carbon market has really kind of avoided, emissions from wells and so forth. But now what we've got is a growing array of carbon registries that are offering for different scenarios to offer carbon credits for well plugging and eliminating those emissions. So the ACR has come out. They're right now focused on orphan wells. I believe that they are going to probably within maybe the next year add abandoned wells, which are idle wells. B carbon is, I would say, focused on idle and orphan wells. Carbon Path has a couple of different, two different, protocols for, high volume and low volume with different focuses. Onyx and 06 they're looking at really more, permanently plugging producing wells, fields, and so forth. But there's we've talked to several other registries that are working on this. Vera is one, and I think they're getting pretty close. But and I will say this is depending on your situation, and here's what we're looking at is I think that if as a project developer and third party verifier validator, and depending on the registry, we try to look for the people that we work with or that talk to us about, hey, in your situation, this particular registry might be best for you and for the wells that wells that you're dealing with, or maybe you got 100 wells you want to plug. Well, some of these are best over here, some of these are best over there, just in the situation of what they are. And I think that we're going to be seeing more of these, and there is certainly a process. So I'm not sure, how everybody's looking at this, but having these registries out there is just so critical. We have an enormous problem being able to have incentives from this, and I hope it expands to some of the wells like I talked about earlier, like those wells in the Arkansas River that I've been out there on my raft and can't get any emissions measurements. They're dead wells right now, but you never know what's going to happen. And that's not to say that they may not be an issue with groundwater or other things with, depending on the different things in mind. So I'm hoping that expands, and I know that's a priority of mine, but these are, I'd say some really good options. I encourage you to visit the sites, download the protocols, try to get to understand those, and if you got questions, I think there's folks on the call that can help you, and I'm certainly happy to talk to anybody about these. So one of the other things that we wanted to talk about was doing things right, and I would say when it's come to plugging, just in my experience, I've been doing this a while, is price has often been the leading measure in getting a well plugged. Who can do it the cheapest? And what I want to make sure of is, or I would encourage everyone of, is maybe what I should say, is, I have no problem, doing things on a low cost basis as long as you're doing it right. As long as you're meeting those requirements and not cutting corners. We've done a lot of auditing. We audited, this was, probably 10 years ago, where we audited a plugger where there was issues. And we went out there for a week, and one day the plugger plugged 10 wells in one day. And, every one of those wells had to go back in and actually be plugged. So sometimes, people are doing things and they see the dollar signs out there. So I'll just say that, it's I think our ethical obligation. We got to make sure we do things right. And when we look at that, these are complicated things. And I'll tell you, if you've been out on the back of a rig or out there doing this stuff, it's hard work. You're out there maybe in the heat or the cold or the weather, and out in the middle of nowhere collecting soil samples or doing whatnot. And I just say that it's a complex thing. And again, I will say, it's a multidisciplinary approach. So as you look at these old wells and the situation they're in and access and the reservoir and all the things, just make sure that you're considering those things as you get done, as you go through the process. So last slide, or next to last slide, federal regulations have authorized, almost $5 billion to address this issue. A lot of states have gotten their first, allocation of $25 million to plug wells. The next allocation will come up in this next fiscal year that I'm hearing is, $60 million per state plus, depending on the state. So a lot going on there. A lot of states have like Texas has already run through their first allocation. And I know a lot of states are worried about just meeting the requirements and so forth, but this is, this is good stuff that the federal government is doing in this. Addressing this issue can be, complicated. It requires, multidisciplinary things, which I've harped on. Development expansion of applicable regulations that's going to happen. So please, be prepared for that. Best practices, implementation, and training to get more and more people trained up so that we can have more people to do this. I know we had one of our guys that was new, had a construction background. I sent him, out to work on the back end of a rig with CSR Services up in Ohio for a month. And it was just so helpful. I will say that historic value and preservation is a big consideration. So I'll tell you, I know a number of landowners that have old wells on their property. And although when they were developed in, say, 1890, all the trees were cut down, but now they're all grown up. And they don't want their their forest cut down, but they also see value, historical value in a lot of that old equipment. So I have a lot of old stuff that I keep around me that I've collected: wooden casing, wooden sucker rods, all sorts of old wrenches and various different things. So just keep in mind, is when you go to these places, there's a lot of oil field museums around the country and people that collect that stuff, and just trying to do that is, I think, is important. I think the carbon credits are imperative within this, and help to fund some of this and offset some of the costs. I know we talk about, you hear, oh, you can plug a well for $10,000 or $20,000. I would say that what I've seen just in general is, costs of, $90,000 to $150,000 is not atypical. And that doesn't count oftentimes site restoration. So it can depend on a lot of different things. And that's not to say that you can't have some wells in some areas that are old, shallow, no pressure that you can plug for $10,000 or $20,000. But that's not the case in a lot of areas. I've seen multiple of these wells or wells out there that have taken well over $1 million to plug. So, and last thing here, and I'd say this, I put this in for Susan Nash, is that shortcuts can result in worrisome and exacerbating a problem. So just, do your best. For me, if contact information, I put in the comments earlier, but if you'd like to get a hold of me, I'm around and love talking to people. So Susan,
Thank you. That was great.
So
yeah, that was great. Well, we have some questions in the chat. So now this begins, and let me scroll up and find the first one. Let's see. Okay, Dan, do the carbon registry organizations require permanent cessation of future oil and gas leasing by mineral owners to obtain credits?
So I would say that that depends. If you look at, say, just for example, 06, those mineral leases essentially get a something on the lease. It's what's the word? Kind of like a conservation easement on a surface property, so that you can't do that. Some of the other ones don't. So it really depends, and I encourage you to go to those protocols.
Yeah, and I would add that so this brings up an issue, and that kind of ties to another question that came up. Some of the protocols don't bring into any kind of consideration the royalty owners or the mineral owners. And obviously, if you don't consider them, there will be a legal issue sometime now or later. and the thing is that because basically you're condemning their reservoir. Now, in the case of an orphan well, I believe it's the well, it's not the entire reservoir, it's that well, that is that your understanding? That it's not the reservoir, it's that well.
So I would say that, it depends again. But I'll say for registries like, say, like B carbon, you're looking at this from a well that is a well basis that is no longer economic. Now, does that mean that someone can't come in and, later time, oil is, $1,000 a barrel, and come in and drill horizontal in there and maybe capture that oil? I'm not sure that that's precluded, because this is for that well. But again, if you look at the 06 thing, that's a different angle. And although I will say that in what I'm seeing, I know that at B carbon, we're certainly looking at that and trying to assure that when we see these wells that are shut in, that it's the same thing if whether the carbon credits were there or not there. A well reaches its economic life, and if there's not other ways to utilize that well, there's not a lot of future for the mineral interest owner on that particular well, regardless. So I will say that what I've seen is the registries are aware of that, are thinking about that as well.
Okay, great. Yeah, that becomes complicated. Okay, so let's see. Scrolling up. Timothy Baker says that I would offer that orphan wells can also potentially emit poisonous gases like H2S and other greenhouse gases like CO2.
I agree. So I would say it's even more than that. And if you look at you know, some of the pictures I had of, you know, doing things right, the one picture on there from that had Curtis Shuck from the Well Done Foundation, that was a well that where there was actually H2S emissions in there, which is part of why he had a mask on.
Yeah, good point. Maria Cristina Silva says, I would like to offer from the carbon offset perspective that wells need to pass an additionality test to generate carbon credits. With the Regrow Act, idle wells don't pass that additionality test.
So, yeah, I would love to talk to Maria about that, but I disagree with that. So if you look at even orphan wells, let's just say if we disregard idle wells for a minute. If you look at orphan wells, all the orphan wells are required to be plugged. So if an individual company hasn't done that, it's the state's responsibility now to plug them. But within that said, if you have an idle well that is a problem where a state or a regulatory agency or because of a lawsuit or whatever is saying you must plug that well, you know, that's a very different thing. So there are circumstances, I'd say, in both of these where a well could not qualify for credits. That's certainly the case. But I would say both orphan and idle wells can qualify, and you know, ACR is certainly looking at that as well as, and so are others, you know, in this. And I'll say the other thing that we're even looking at that even kind of goes back to your question, Susan, is what we're seeing in the Permian Basin and other areas is companies going in and actually buying the minerals to not develop them and try to get credits in that way. So there's a lot of things out there that are going on. And I'll tell you that when we start thinking about additionality and qualifications, all these different things, you know, the idea of credits has been going on for a while. And but when you look at, you know, carbon credits, carbon offsets applied to idle and orphan well plugging and so forth, you know, methane emission reduction, this is brand new. I mean, you know, I hate to say it, but this is, you know, this is not what those registries have historically been doing. This is a new thing. And it's developing. There's going to be more registries. There's a lot happening. So I would just keep that in mind. You know, so things are going to evolve. Things are going to get more and more escalated in all the details.
I totally agree with you, and I think that one of the things that we have to be careful with is the over-enthusiastic condemnation of reservoirs. I think it's one thing to plug, and it's one thing and to say, okay, we're going to plug this well and also this reservoir that's uneconomic, and it can't be and it's going to be plugged for 20 years or whatever it is. But when that can be taken too far to the point that it becomes a wholesale assault on mineral owners' rights and royalty owners' rights. So I think that this all the unintended consequences need to be actually thought through. I mean, at least we need to discover this unintended consequences and make sure that it's fair. I mean, speaking of ethics.
I agree, and I could just tell you from my perspective, we're trying to look at those and advising, you know, clients and companies and so forth along those ways. And but it's, you know, it's new ground, and I would say that, you know, what I'm seeing is a lot of people trying to do, you know, some really good things, and these are certainly, you know, a lot of these old wells, whether they're orphan or idle, non-producing are, they're something that my emphasis that we get those plugged, and the emissions from them, the groundwater, the surface site ground, all of that. It's just huge.
Well, right. And also in another case too, there's the scope 3 impact, which is to say that, for example, in the case of a well that's making a half a barrel of oil and 100 barrels of water a day, then if you extrapolate that out to 20 years, you saved the carbon footprint from all of that water hauling cost. And if you have a saltwater disposal well, which is probably unlikely, then you've also potentially, and not that this is measurable, but you've helped reduce the potential of induced seismicity through all of that.
Oh, there's a lot of things, and even the the emissions from, like you said, not only water hauling, but pumps, and there's a lot of indirect positives here.
Okay, so great. Yeah, absolutely. Sanford Kaplan says, in solid waste landfills, operators in some states are required to set up a fund for closure and remediation as a part of landfill application process. Is this potentially going on with new wells as present? Well, I think, yeah, you have to put a bond.
Well, so I would say this varies. So, back in the 80s, I worked for the U.S. Environmental Protection Agency in the underground injection control program. So for an injection well, you have to have a bond for that well. But what's happened in oil and gas development and states and so forth is some operators can have hundreds, maybe thousands of wells in a particular state. And so we came up with the idea of blanket bonds for active operators with those wells. So the challenge there is those blanket bonds don't typically cover the full plugging liability that you may have. And I would say that there's some states like state of Arkansas and some others that are really, re-looking at this. It's a fine balance because you're trying to, promote development and taxes and development of those resources in your state, and you don't want to run people off and go, well, instead of doing something in Oklahoma where they have these high-priced bonds that you get, I'll go to Texas or vice versa or whatever it is. So, there's a lot to consider within this.
Yeah, that's a good answer. Yeah, I totally agree. Okay, Terrace Barr says, do modern best practices ensure all wells are plugged and decommissioned at the end of life for wells being drilled in the last decade or two? Or do we still have orphan wells happening?
We have orphan wells that have come about in the last 5 years. So, this is one of the challenges we have is, the oil and gas industry has certainly been I've been through more booms and busts than I can imagine. And, in 1986, I thought I was going to go to work on the North Slope for ARCO, and oil went to $6 a barrel. They retracted my offer, and I went to work for EPA, earning $18,700 a year as my first job. But I needed a job, and what I'll say is that then, and as you go through over time, at least from there to the future, we've had many boom and bust. Companies go bankrupt, and it's not even unlike, it's not unique to oil and gas. I mean, you look at the steel industry or a housing industry, or so many different things that can have those things happen, and it can be unfortunate, but a lot of times those assets, if they have value, they may get picked up or sold or whatever. But it's stuff happens.
Excellent. Okay, Edgar Palaez Are P&A operations performed typically in an integrated way, operationally and business-wise, or by a collection of discrete services that converge on a well for P&A?
The challenge I have with Edgar's question there, and Edgar, thank you, but when you say typically in this, that's a hard one, because I'm not sure there is a typical. I've heard, like at our last workshop that we had in Oklahoma City on plugging and abandonment, we had one speaker come up and say, every well is different and so forth. So I would say that we are getting better at doing this on a, if when he says integrated, I think I don't understand what he means there, but with looking at more of the global scope of what these things are, and not just going, well, I put 2 plugs here and do whatever and I'm done. So we're certainly looking at a lot more details and big picture of a lot of the stuff than I would say that we ever used to.
Yeah, that said, there is a new role that's come up, and I think it's not unusual in the 20-year history of carbon projects, which is like forestry, agriculture, maritime, marine, that now it's going to oil and gas, and it's new to us. But there's a role of I always forget this. I think it's project producer. And so the producer is the integrator.
Well, you have a project developer,
Developer, okay.
That'll generally do that. And if you like Google the difference between, say, a project developer and a project manager, I would say that's a good thing, but there's still a lot of different things that have to be done, from regulatory and getting the permits and all the things that, when we do this, I've got, my engineer and my biologist and, different things, and looking at this, and, maybe you're going to, looking at phytoremediation for the surface, and I'm calling up biosqueeze because, I've got a gas issue and that I need to address. So it can be more complex depending on the specific situation or well or group of wells than you might anticipate.
Excellent. Okay, Jorge Foss says, where do you think the disconnect happens between abandoned wells and having a professional obligation to include and disclose ADR costs, abandonment, decommissioning, and restoration in project evaluation?
That's a tough one, Susan, and I will just say that historically, wells that, let's just say, would become unproductive or uneconomic at that particular time would be held on to. And there's been several cases where some of these wells might be recompleted, and I think that there's often a lot of hope for that. But sometimes, even over years and years of holding some of these wells, they never, that option never really materializes. So I'm not sure that I would say necessarily a disconnect or whatever, but when you're looking at, you've got this well that's there, if you plug it, those resources that potentially you may be able to get, you could never economically drill a new well and get those. So I'm not sure that I can necessarily answer that, because that would be a discussion in itself, I'd say.
Okay, yeah, I agree. Okay. Do you have any thoughts about offshore orphan wells offshore. That's scary to think there are offshore orphan wells.
Oh, there are.
Shallow and deep water Gulf of Mexico.
Yeah, so there's actually a number of them out there. That's as well as I would say a number of idle wells that have issues and even plugged leaking wells. Offshore has not been the major focus, although a lot of the majors out there are working on going in and handling a lot of those now. So I think those are, some good topics that are being addressed. The numbers are not like they are for onshore, but there's still some issues.
Okay, so here's a comment from Sanford Kaplan. Thank you for, I learned a great deal about the subject through your efforts. As a working interest owner in a few small wells in Montana, I am very concerned about the plugging of wells as they near the end of their economic life. So, I mean, I guess, so my feeling from that comment is that it's one thing to be the operator, it's one thing to be the project developer or whatever it's called, but it's another thing to be the person who's the non-operating person who has no agency, no authority, except it small, there's some, but not much.
I would say, one of the organizations that I've, have worked with over time is a Marginal Well Commission. And if you look at, this is kind of like before we had the fracking revolution, we were looking at peak oil and, it was all done and we're gonna run out. But a lot of those marginal wells contributed a significant amount of, of especially oil, but also gas, to what we use. So that's, certainly still a possibility. But what I will tell you is we get into how the regulations have evolved, like air quality regulations and managing a lot of those things for emissions. The environmental regulatory systems that are out there are really a challenge. And even with a lot of those marginal wells, over time, many of those ultimately became orphan wells, because now maybe Shell has a project and then they sell that asset to a smaller company, and then they sell it to a smaller company, and finally Susan Nash owns these 5 wells out there that produce a barrel of oil a month, which maybe is providing you some income, but won't cover the plugging liability that you have. And so there's some real difficult balances that we all have to be thinking about, for sure.
Well, you raise a good point. A lot of companies have sold off their projects, and like if you buy a well, like you said, with a blanket plugging, if you buy a package of say 50 wells, then you have maybe, I don't know how much, but like X number of dollars as your plugging bond. And it's definitely not enough to plug all of them all at the same time. And then at the same time, thinking about shale wells and the decline curves versus some of these long-lived wells, it's hard to say if it's really at the end or not, because some of them could just be revitalized with a workover.
Well, and that's, I was talking to an operator yesterday about exactly that, and those are some of the things that you have to balance. So you have a well, and maybe you could go in and work it over and do something, but the workover is going to cost you X dollars, and you might only get, workover is going to cost this, but ultimately what you're going to get out of it is only this, and then you got paraffins or this to deal with or that, or at some point, that you're going on that teeter-totter and you're going, this is just, I can't keep it going.
Yeah, that's a good point. And then if a lot of times this comes down to the cost of a pump or a cost of, like that kills it. It's a deal killer. If we have to put a pump on it, or a different pump.
Yep, or you got your, your casing is shredded and, and this and, it's like I said, it's a complex thing and I truly believe it's a multidisciplinary issue and a lot of those things in the past have been, kind of run by guys with a whole lot of experience. And I'd say our experience out there, the people now have I'd say a narrower band of experience that I'm seeing anyway, and
Well,
it's tough.
yeah, the thing that bothers me, this is just my personal perspective, is that, okay, you said there's shredded casing, et cetera. There's formation damage along in the producing formation. Okay, so that doesn't mean, why should that condemn the entire field? I can see it can, or the
Yeah,
entire lease. And so
that's right.
these ideas that, well, if you're going to get carbon credit, it means you have to keep the entire thing in the ground. I understand it, et cetera, but it's a complex issue.
Michael, I'm okay if you want to ask a question live.
Yeah, please do. Feel free to.
Yeah,
Just don't make fun of me.
Oh, no problem at all. Thank you, Dan and Susan, for putting the session on. I wanted to ask about the guidance provided to the states to acquire the formula funding as part of the Bipartisan Infrastructure Act. In there, it says that states have to write plans to monitor the emissions from wells, but I would think, and I'm in Texas, I don't believe Texas has a plan for that. I'd love to hear your opinion on that. Do you think states are going to go after the federal funding and implement emissions monitoring programs? Or are they going to pass on the funding? And how is this all going to get done? Thanks.
So interesting question. So Texas specifically has worked through all of their first round of funding. And I'm not aware that they've done any kind of pre-plugging emission evaluation on any of those wells. But what I will say, just in looking at the array of wells that they did, they were focused on more wells and that are not emitters. So if you look at that, a lot of the stuff that's been out there, that emission chart from like number of wells is, like those wells that I showed in the middle of the Arkansas River here in Tulsa. I can put my meter up there. There's nothing coming out. And I would say the Railroad Commission has a pretty good handle on that, but they're also very desperately trying to address groundwater contamination concerns and so forth. So I think their prioritization is one thing, and when they can be out there and their guys are out there with, say, a 4-gas meter and there's nothing, what is there to measure? But what I will say is that this is quickly evolving, and I know that there are states that are looking at that. The state of Oklahoma was very slow in doing this, and what they're even thinking of is that, okay, do we use the federal funding? Because let's just say that you're a state and you plug this, the federal government has said you can't get carbon credits for wells that you've plugged with federal monies. Okay, so I've talked to different state agencies, so okay, for the federal funds, maybe we plug the wells that don't have emissions and address that way, and then leave these others where there's different incentives to be plugged by groups, pursuing carbon credits. So I don't know. I just say, just keep in mind, this has been going on like 1 year in an industry that, you can go back to. I know people look at the Drake well, 1859, but the first commercial gas well was 1826 and 1811. you know, I'd say 1801 to 1811, you had wells where they were drilling for salt in Kentucky and Ohio, and they made oil, and they were using that for, you know, to use on ships and so forth. And I mean, so this whole industry goes back a lot further than a lot of people think, and we've got a lot of those to address. So if the states want to focus on that, on those issues relative to that federal funding to make it easier, that's their call, you know. So I think that it will evolve. I will tell you that EPA and DOE have started the new program, the methane emission reduction program, if you've heard of that. I've been asked to be a consulting expert in that program. So I think that as these programs evolve, that we're going to get more and more development, things that are easier. You know, you look at just even the monitoring instrumentation. This is stuff that has been developing rapid fire, fast, you know, so.
Yeah, with regard to the methane reduction program, I saw that $350 million was set aside to help with the technology to reduce methane emissions. Is that specifically going to address wellheads and well sites, or is that more for, you know, industrial facilities, more so than the wellhead itself?
I would say that it's not solely the wellhead. Okay, so but it's on those wells, I think, like, and that's another new program. So you're asking me a question that I'm not sure is actually fully decided, Michael. Sure. So I get you're curious and you want your answers right now, but you know, I'm gonna hold off on that one, and because I don't see one of the EPA or DOE people that are running that program here. So I just say, you know, sit tight, and that's going to come about pretty quick.
Thanks, Dan.
Yeah, that's great. Okay, so I noticed that Les Skinner is here. He has a great question, and I think it would be great if you would ask it live. Les, are you here? Great.
Yeah, I'm here, Susan. Thank you. Can you hear me, first of all?
Yes, perfect.
Okay. The question I had, Dan, and it kind of goes back to the conference we had back in February, where we talked about some of these leaking abandoned wells, involves the state agency going back to previous operators, maybe the people that plug the thing, it might have been a previous operator before that, and requiring them to go back inside the well to re-enter it and replug it. Now, if we talk about cutting corners and a 100-foot plug being insufficient, if you add on the cost of re-entering a well and replugging it, it makes it look like cutting corners during the plugging. Not doing it right is really a false economy. Can you comment on that?
So Les, I appreciate the question. One thing that I've been worried about, and have said this before, that I'm concerned that and remember, I used to work for EPA and worked in various programs, including the Superfund program, where I did some work there too, and I've done a lot of work in my consulting career in there. And I've been worried that this kind of orphan well program is going to turn into a Superfund kind of program where you do exactly what you're talking about. The problem is, and this comes as, I'll just say, as being a testifying expert in cases exactly like what you're talking about, in that it's a challenge. So let's say that Les, you go and plug a well in 1900, and you plug it in accordance with rules that are there at the time, and it's not a problem. And then I come along and I put, say, you know, an EOR project in, or something that you could have never anticipated. And now that well that you plugged in accordance with regulatory standards starts becoming a problem. So is that your fault? or is it mine? You know, or I put in a CO2 sequestration project that could have never been anticipated in 1900 when you plugged that well, or think of all the other different, you know, there's so many scenarios. So, you know, that's a tough one to think about.
Okay, thanks, Dan.
And that is really tough. I think, well, this has really been an amazing session. And thank you, Dan, for all the questions and for the presentation and for responding to people's questions and kind of doubts or, oh, okay. So Robin Swank said, what you're describing was circumvented in Colorado. Horizontal wells drillers have to re-enter and render old vertical wells incapable of production on their own dime. Huh, interesting. Thanks, Robin.
Well, so Robin, on that one, so we've done things where, and not just in Colorado, but in Pennsylvania, in Ohio, and a bunch of places where we've had to go as part of like new unconventional programs with horizontals, have had to go into and plug old orphan wells to make sure, you know, that we're left unplugged and so forth. So, you know, that's being done where the new unconventional operator is going in to do that. So they want to go develop those resources. So they're, you know, they're addressing those issues.
Yeah, that's right. It's actually a condition of drilling the well. You can't drill the horizontal well until you complete all the mitigation ahead of time.
Yeah, it just, you know, if you want to do that, but that's, you know, so you could use that there. But I could give you another example is like as part of the underground injection control program, you do your area of review. And if you have wells in that area of review that aren't plugged or aren't plugged properly, you may have to get a permit. To get that permit, you may have to go in and plug or replug some of those wells for you to get a permit to do that. So there's multiple examples in how some of those things can come about.
Sure. Do you feel that this is an evolving cost that's going to be the cost of doing business going forward into the future? Is this something we can actually, you know, work through, or is it just something that now it's the cost of doing business?
I'm not sure what you mean. You mean plugging wells as you like that? If you want to do that for a project, so like we've had to do that for EOR projects, for CO2 sequestration projects, or CO2 EOR projects. So that's, I don't know. It's like that's been the cost of doing business. So
I guess that's my point.
but if you're in that area where like sometimes it's difficult to know, you know, what that is. So like on the water disposal front now, you know, when I was at EPA in the 80s, a high volume injection well was about 5,000 barrels a day. You know, we've got wells out there now that are injecting 100,000 barrels a day. And, you know, we have a lot of issues. So is dealing with induced seismicity a part of doing business? Is, you know, there's a lot of challenges, I think, in our industry that we have to deal with, but there's a lot of opportunities, like, you know, here in Oklahoma, where you know, maybe you have a commercial disposal well and you're taking water that's high in iodine concentration. So you can extract that iodine before you put in your well and have a second income. We have a client that takes oil field waste in West Texas. Their name is EcoStream, and we help set them up with, you know, with equipment and so forth to take those tank bottoms and other waste they did, separate it out. So now they're getting paid to take the waste. We're separating out the oil. So out of two facilities, they're generating, you know, X numbers of barrels of oil that they're able to sell as an add-on income stream and so forth. So, you know, I think we have to look at, you know, that ongoing cost of doing business, but what are the other things that we could do to do things better and increase our our income. So I really try to work with clients on trying to find those add-ons. So you're doing geothermal, well, hey, geothermal and lithium, or geothermal and whatever, and and there's opportunities that we don't always think about because we get focused on one thing and so forth. So, Robin, thank you so much. I'm going to have to run
Yeah,
here.
I think we're,
Thanks
yeah,
everybody.
we need to, yeah, thank you, Dan. And yeah, I know we're way over our time commitment, but thank you. And thanks for everyone for attending. And if you have any questions about getting your certificate for participation for professional development hours, I put the link in the chat. You'll have to scroll all the way to the top to find it, and click on that and just click to register and pay, and then you'll have it and you'll get your certificate via email. So thank you, and thanks again, Dan. That was amazing.
All right, take care, everybody.
Thanks.